Hello everyone, my name is Ristama Aklantanjaja. Graphs coverings and their applications say a Negami. Graph covering. The meaning of graphs coverings is there is a bijection between the neighbors of corresponding vertices. The word bijection may or may not be in the English dictionary. It is a difficult word. Imagine a big circle, and it's covering a small circle. They're called covering graphs. On the circles lay many numbers, and each number on the covering graphs appears 4 times. Those numbers are the exact number as the box that gets projection from the covering graphs, which is called base graphs. Those numbers indicate correspondence between the covering graphs and the base graphs. Graphs covering is a method to make a huge network despite once being a small one. The covering graphs cover the base graphs. For an example, at the base graphs there is a triangle that contain number 5, 3, and 1. Those numbers have a long cycle when they are in the covering graphs. They go on loop 4 times. A huge graph covers a small graphs. If a huge network has some kind of graphs covering, we can make a rapid algorithm to find so many things. As an example, there is a graph. We can open it up and find bunch of object we want. Planar cover conjecture 1986. If a connected graph G has a finite planar covering, then G has two-fold planar covering. There is a network, but we can also call it a graph. It has a cross in the middle, thus it can be an electric circuit, but if we cover the graphs into a bigger one, we can work it out and call it a two-fold planar covering. Composite coverings. There is a small graphs and a slightly bigger one, also another version of the slightly bigger graphs. The bigger graphs is covering the small one. We can call it a two-fold. And there is another huge graphs covering the slightly bigger graphs. We can call it a four-fold. It is 2 times bigger than the small graphs. The huge graphs can be two things. This is the slightly bigger graphs, and the small graphs. This is often referred to as composite coverings. The huge graphs can cover the slightly bigger graphs, but it cannot cover another version of it. Intermediate doublet coverings. The huge graphs can cover the small graphs and the slightly bigger graphs. How come it couldn't cover another version of the slightly bigger graphs? Those questions can't be answered even if you use a quantum computers. The only way to solve it is using a superset of T spanning tree. Those many versions of the graphs can be constructed using the spanning tree to get a small graphs.